This lecture, we're going to talk about containers. Containers are kind of the new kids on the block, although they've been around for quite a while, but they've gotten a lot of buzz and use these days. So the goal is we have an executable and we want to package it in such a way that it's isolated from other executables and that it's lightweight in terms of loading and transferring. So if we look at the types of packaging, you can package something as a process, which gives you isolation in terms of the address space. Doesn't give you isolation in terms of files or networks, but it's lightweight. Or you can package something as a virtual machine, which gives you isolation in terms of address space, files, and networks, but it's heavyweight. So you might guess that containers sit in the middle. Containers isolate the address space, they isolate the files and networks, but they're lightweight. So the preeminent container system is Docker, although there are other alternatives. So if you look at Docker compared to a virtual machine, to a collection of virtual machines, and you see that each virtual machine has its own operating system, its own application, its own layers, middleware, whereas with containers, you actually are sharing software. So you share the operating system. There's something called the Docker engine, which is new, and you might share the middleware as well. And if you look at how the Docker architecture is, when the key idea is that there's a distinction between Docker images, which are like VM images in the sense they're just a set of bits, and Docker containers, which are executing. So that if you're going to run a container, then you're in the container side. If you're building it, then you're in the image side. There's some other superstructure in the sense that there's a client which is typically independent of the place where the container and the images live, or the container runs and the images live, and that's where you execute the Docker instructions. So you can run, you can build, and so on. The other piece of interest here is the repository, and we'll get to that in a minute. So the way that, well, there are several ways, but one way that the Docker container gets to be lightweight is because of it's structured in terms of layers. So if you want to build an image, you start with a base image, let's say Ubuntu. You load software, and then you commit that base image plus software to form a new image, and you can do this multiple times. And then the new image is, as I say, the base for more software. And the image is what's transferred when you move from one to another. So if you look at just the operating systems around a gigabyte, fast network somewhere around the notion of a gigabit. If they're 8 bits per byte, transferring an operating system at full bore at full speed would take 8 seconds. But in practice, a 1 gigabit network is around 35 megabits in practice, so it's only a third. So that means that just loading an operating system, regardless of anything else, is going to be at least 30 seconds. And so if you share the operating system, you've saved a minimum of 30 seconds per instance. The more you save, the more you share, the more you save. And the other thing about containers that makes them lightweight is in the updating, not the initial load, but the updating. So you only update the new layers. The unchanged layers do not need to be updated. And so part of the execution engine is that it knows how to manage the communication from one layer to another. Again, transferring less software and making the update faster. So if you have a virtual machine, you have all the freedom you have with a bare metal, slightly fewer resources, but you can choose your operating system, you have total control over networking and files. A container is constrained. Okay, you're sharing an operating system, so you have to have an operating system that's shareable and that's been set up to be shareable. Uh, at this point, I think Windows and OS X are potential operating systems. Certainly Linux. Uh, you have freedom in terms of networking, but it's limited. You have freedoms in terms of file structure options, but those are limited as well. Okay, so that is that's building one image on one machine. Okay, what you did in the exercise, Docker exercise. Now let's talk about allocation. So I have a collection of images that uh, represent different applications. I have a collection of hosts that might run it. Uh, in manual Docker, this is done manually. So you have to specify which host will run which image. So Docker has a concept called a swarm, which says that I can group hosts and into a swarm. So a swarm from the point of view of allocation looks like a single image, like a single host. And so then allocating it is a matter of saying I want to allocate this particular image to this logical host, and the system will pick one. Okay, and so there's something called a swarm master that actually does this. So you send the run request to a swarm master, it picks a host, and allocates the image to that host. Okay, so how do the containers get to the hosts? Well, they can be copied at each invocation, which is sort of what I implied in the last slide. Copying time is overhead, but it makes the host flexible. They could be preloaded, and so then there's no copying time. But then the allocator must allocate to host with the appropriate containers, and AWS has a feature called Lambda that exploits this one. Or some layers can be preloaded on the host. Actually, this is what Lambda exploits. And so then you have the copying time for additional layers. But once you have preloading, then you're constrained to allocate an image to something that can run it. It's possible to have multiple swarms, and then you have different tokens that tell you which swarm you want to belong to, or you want to allocate to. That takes care of allocation, but doesn't take care of across multiple hosts, but it doesn't take care of scaling. So if you want to auto scale swarms, then you have to place the swarm and use the auto scaling facility. And AWS has a container management facility that does all this. It doesn't actually use swarm, I don't believe, but it does do auto scaling. And so if you can read this, if you can, it's on the internet. That's where I grabbed it. A request comes in, it goes to an elastic load balancer. It may be allocated across availability zones. From the elastic load balancer, it goes to the container inside hosts. So the elastic load balancer could allocate new containers and so on, and then there's supporting software underneath. So Lambda is an AWS facility that has preloaded operating systems and execution engines, and it exists for common execution engines. And they maintain a pool of partially loaded containers that only require application specific layers. So the loading is done just to load the layer that has the application on it. It's done in microseconds. But they also constrain you to one request per Lambda instance. So these are inherently stateless. You have a request, it allocates something, it responds to the request, and then it deallocates it. Okay, so how does this work with workflow? So you have multiple team members, and they may want to share images. And images can be in a variety of states, right? They can be in production, they can be under development, or they can be under test. So Docker maintains, or Docker has something called Docker Hub, which is a repository. They actually have there are various ways that you can use Docker Hub. They open source the repository code. And that's where images stored can be stored and shared. Again, your exercise stores the image that you did with Docker into a hub. And then each image is tagged, and so you can have versions of image, and any image can be pulled to any host as long as you have the appropriate credentials. And if you tag something as the latest, it allows updates to be propagated. If you pull a particular image name latest, then you get the latest image that's posted into a repository. So in your exercise, you built something on VirtualBox, you stored it into a Docker Hub, and then you pull it from a EC2 container management. So it goes into Amazon instead of VirtualBox. So to summarize, containers are a lightweight virtual machine, and it provides isolation of address space, networks, and files. It allows building images in layers, and deploying of a new version just requires deploying layers that have changed. Containers can be managed on virtual machines through auto-scaling, or if you're using Lambda, on a pre-allocated pool for short duration quick loading. And the development workflow is supported through an image repository.